Welcome! Right now, we will be tackling about buoyancy. So, what is a buoyancy? We are all aware of the fact that some objects float in water and some may sink. For example, this balloon. Well, it is the upward force that is exerted by the water that makes the balloon float. In order for you to experience this, try pushing the balloon downward. You will feel an upward force in the balloon, and it makes it difficult for the balloon to be pushed down. Now, if you release the balloon, it bounces back to the surface. What happens here is that the applied force acts upon in the downward direction. It is pushing the balloon down, but the water is exerting an upward force pushing the balloon up. This upward force is known as the upthrust or buoyancy. The upward force is called the buoyant force. Now that we are done tackling about the Archimedes principle, now let us proceed to what is the definition of a buoyancy. So buoyancy is a vertical force acting in the opposite direction due to gravity. It is often experienced in floating bodies such as the balloon that we have given as an example. So now, this is the formula of buoyancy, which is BF is equals to FB minus FG, where FB is given as the buoyant force. And Fg as the gravity force. So, right now, we will be having a derivation which is unit Vb minus unit Vg is equals to unit open close Vb minus Vg, which could give us the final formula as Bf is equals to unit times V. And V here stands for the volume. So this is the basic formula of the buoyancy. After giving the basic formula of buoyancy, right now, this is for the homogeneous solid body of volume floating in a homogeneous fluid at rest. So, this is the formula. Vd is equals to specific gravity of body over specific gravity of liquid. Times the volume, or equals to unit body over unit liquid. Times the volume, where unit is the unit weight of fluid. And Vd is a volume displaced. If the body of height has a constant horizontal cross-sectional area, such as vertical cylinders, blocks, etc., then this is the height. And from here, this is the distance. So the formula for distance is specific gravity of body over specific gravity of liquid times the height, or also equals to unit body over unit liquid times height. If the body is of uniform vertical cross-sectional area A, the area submerged AS is to be given as like this. So right now, we will draw a circular broken lines. So after that, we will now proceed to the formula of AS is equals to specific gravity of body over specific gravity of liquid times the area, or equal to unit body over unit liquid times the area, where A is equal to area. So this is the formula. After learning about the formulas of buoyancy, now let us proceed on the examples. So, example number 1. An iceberg having specific gravity of 0.92 is floating on salt water surface is 100 cubic meter. What is the total volume of the ice? So, the first thing that we need to do is to draw the free body diagram. This is the iceberg having a specific gravity of 0.92, and this is the water level. And this is the weight of ice. And then this is the buoyant force having an upward direction. And this is the seawater having a specific gravity of 1.03. So the first thing that you need to do after drawing the free body diagram is let V is equals to total volume of ice and VD is equals to V minus 1000. So VD is equals to unit body over volume liquid times the volume body. So V minus 1000 is equals to specific gravity of the iceberg, which is 0.92 over 1.03 times the volume. We will be having the volume of 9,364 meter cube. So this is the final answer of your volume. So that is all for the topic of buoyancy, and this is the end of our tutorial. Thank you for watching.